All right, welcome back. This time we're going to go over questions 141 to 160 of the AWS Machine Learning Associate exam. So before we get started, hit the like button, subscribe, and share with anyone you know taking the exam. 141. Companies processing genomics data for research. The workloads require custom processing containers, high memory instances, and the ability to use spot instances for cost optimization. Which AWS service is best suited for this? Batch, Glue, SageMaker Processing, or EMR? A, Batch. It's designed for batch computing, supports custom Docker containers for specialized genomics, supports spot instances for up to 90% cost savings, supports memory optimized instances, automatic scaling based on job queue, and no infrastructure management required. What's the benefits for this? You have custom containers for bioinformatics tools, high memory instances up to 24 terabytes of RAM, cost optimization with spot instances, job dependencies and workflows, and parallel processing. Why are the other answers wrong? Glue is an ETL service. SageMaker Processing is for ML data processing, not general batch compute. And EMR is for big data frameworks like Spark and Hadoop, which is overkill. 142. A SageMaker training job with 1 terabyte of training data is taking too long to run. The data is stored in S3 and Parquet format. The engineer wants to reduce training time. What should be done to speed up training? Use file mode to download all, pipe mode to stream from S3, convert it to CSV, copy data to local instance storage. B, pipe mode. This streams data directly from S3 to training algorithms. There's no wait time for the 1 terabyte dataset download. Training starts immediately. There's lower storage costs, so there's no EBS volume for data. It's optimized for large data sets, and it works well with sequential data access patterns. Performance comparison. File mode, you download it first and then train. Pipe mode trains immediately, streaming as needed from S3. So why are the other options incorrect? So file mode has the initial download. CSV, well, Parquet is already optimized by being compressed. CSV would be slower as it's raw. Local storage still requires copying time, which is similar to file mode. 143. What's the format in which SageMaker models are stored? PKL, H5, .tar.gz, .json. C. SageMaker stores models as .tar.gz compressed tarballs. This contains model artifacts, parameters, and metadata. It's stored in S3, standard format across all SageMaker algos. It's easily portable and deployable, and supports versioning and lineage tracking. You can see the contents in that model below. Why are the other options wrong? So .pkl is a Python specific. .h5 is a Keras or TensorFlow format. And .json is for metadata. 144. A company wants to use a pre-trained model, foundation model for a specific image classification task with only 200 images per class. Training from scratch is not feasible due to limited data. Which approach will yield the best results? Train a new CNN from scratch, use transfer learning, use unsupervised learning, use KNN classification. B, transfer learning leverages pre-trained features from ImageNet, which is millions of images. 200 images per class is sufficient for fine-tuning, not for training from scratch. Freezing early layers preserves universal feature detectors like edges and textures. You can only train the final classification layers on the specific task. It prevents overfitting with limited data. And it's much faster training, hours versus days. And what's the process? You load the pre-trained ResNet 50, freeze the convolutional layers, replace the final classification layer, train only the new layer with 200 images per class, and optionally fine-tune the top layers. So why are the other answers incorrect? Training from scratch requires tens of thousands of images. Unsupervised, well, there's no use of pre-trained knowledge or labels. And KNN on pixels is a poor feature representation and doesn't use pre-training. 145. Learning curve is a graph that compares the performance of a model on training datasets versus validation datasets over varying numbers of training instances. The learning curve represents a model that is underfitting. Which of the following solutions would you use to fix the issues? Select 2. So there's supposed to be an image here, but I forgot to add it. Okay, so options: increase regularization, decrease regularization, remove features, add more features. So if it's underfit, then you want to add more features and you want to decrease regularization. Yeah. So decrease regularization and add features. Yeah. So underfitting characteristics, high training error, high validation error, small gap between the curves. Both pair errors plateau at a suboptimal level, so the model is too simple. So decreasing regularization. Why do you do this? So current regularization is over-constraining the model. Reducing regularization allows the model more flexibility. The model can fit training data better and increases the model capacity. Adding more features. More features provide more information to the model. This helps capture complex patterns in data and increases model expressiveness and addresses insufficient model capacity. So those solutions include: one, decrease the regularization, add more features, increase the model complexity with more layers and neurons, train it longer, and use more powerful algorithms. Why are the other options wrong? Increasing regularizations worsens underfitting. Removing features reduces information. 146. A data scientist is facing the challenge of high variance in a machine learning model, where the model performs well on training data, but poorly on new unseen data. Which of the following methods would most likely improve the model's ability to generalize, adhering to responsible AI principles? Increase the number of parameters, use early stopping once performance degrades, remove cross-validation, train on smaller subset. B. All right, so high variance means overfitting. So that's good training, poor test performance. Early stopping monitors the validation performance. He stops training when the validation performance starts degrading, and it prevents the model from memorizing the training data. This adheres to responsible AI by improving generalization, and it's the automatic prevention of overfitting. So early stopping process would be to monitor the validation loss during training, track best validation performance, stop if the validation loss increases for n number of epochs, and restore the best model weights to prevent overfitting automatically. Why the other options are wrong? More parameters increases the model capacity, so it worsens it. Removing cross-validation reduces the ability to detect overfitting. A smaller data set reduces the training, worsens overfitting. 147. A robotics company is using SageMaker to train a reinforcement learning agent to navigate through a dynamic warehouse environment. During training, the agent sometimes moves farther away from the goal instead of closer. What is the most likely cause of the behavior? Adjustments to action space, negative rewards or penalties, adjustments to policy functions, positive rewards. So positive rewards. So it's incorrectly configured. So the agent is being rewarded for moving away from the goal. This reinforces the wrong behavior. The reward function is incorrectly designed. So the agent learns moving away equals good due to positive rewards. The reward shaping is critical in reinforcement learning. So the correct reward structure would be move toward the goal plus 10, move away from the goal minus 10 or 0. So the incorrect reward is what we're already getting. And you can see that. If it moves away from the goal, plus 5, that's a positive reward for bad behavior. So why are the other options wrong? Action space defines possible actions, not reward behavior. Negative rewards would discourage moving away, not encourage it. Policy function maps states to actions, but driven by rewards. 148. A company needs to ensure data quality before training machine learning models. The data pipeline should automatically detect schema changes, missing values, and statistical anomalies in incoming data. Which AWS service provides these capabilities? Glue, SageMaker Data Wrangler, Glue Data Quality, Macy. Glue Data Quality. This is built for automated data quality checks. It detects schema changes automatically. It identifies missing values and anomalies. There's a statistical validation rules. It integrates with Glue ETL pipelines. There's continuous monitoring of data quality, and there's alerts on quality issues. So data quality features include schema drift detection, completeness checks for missing values, statistical anomaly detection, custom validation rules, and quality score metrics. Why are the other options wrong? So Data Brew is an interactive data preparation. Data Wrangler is for exploratory data prep, and Macy is for PII detection and data security. 149. An engineer needs to deploy a model that requires GPUs for inference. The traffic pattern is unpredictable with sudden spikes. The solution must minimize costs during low traffic periods. Which deployment is best? SageMaker serverless, SageMaker real-time with auto-scaling, and min at 0, SageMaker real-time with auto scaling and min at 1, and SageMaker asynchronous inference. All right. C. So GPU instances are required. Serverless doesn't support GPU. Real-time inference supports GPU instances. Auto scaling handles unpredictable spikes. The minimum instances of 1 would prevent the cold start for the GPU. The acceptable cost for 1 GPU versus slow GPU cold starts is there. So this is the best balance of performance and cost. So the considerations include the GPU cold starts can take minutes, which is unacceptable. The min of 1 ensures an immediate response. This can auto scale up during spikes, and it can scale down, but not to 0 during low traffic. So why are the other options wrong? Serverless doesn't support GPUs. Min 0 means a cold start, and asynchronous is for long-running inferences, not spikes. 150. Financial institution must ensure all model decisions are auditable for regulatory compliance. The solution must track what data was used, how the model was trained, and which version is deployed. Which AWS service provides this? SageMaker Experiments, SageMaker Lineage Tracking, CloudTrail, SageMaker Model Registry. Lineage Tracking. This provides the complete audit trail for this. Automatically tracks data, training, model, and deployment. Its queryable lineage graph for compliance is included. It captures all artifacts and relationships. It's built specifically for machine learning governance. It meets regulatory audit requirements. So lineage tracking captures dataset versions used for training, training job parameters for code, model artifacts and versions, deployment endpoints, and completely reduces the chain. So why are the other options wrong? So Experiments tracks runs, not the complete lineage. CloudTrail is for API logs, not ML specific. And Model Registry has the model versions only, not the full data lineage. Question 151. The company is training a sentiment analysis model on customer reviews. The model performs well on short reviews, but poorly on long reviews, over 1,000 words. The model architecture has a maximum sequence length of 512 tokens. What's the best solution? Truncate all reviews to 512, use hierarchical attention to process long documents, split long reviews into chunks and aggregate predictions, increase the maximum sequence length to 2,000 tokens. Hierarchical attention. This processes long documents effectively. It breaks documents into sentences, then aggregates. It captures long-range dependencies. No information is lost from truncation. It's designed specifically for long documents, and there's better performance than simple truncation or trunking. So the hierarchical approach can encode each sentence separately, apply attention across sentences, aggregate to document level representation, and captures both local and global context. So why are the other options wrong? Truncate would you lose important information. Chunking may lose context, and increasing length would be memory intensive and may not fit in the GPU. 152. A company wants to use SageMaker Studio for development. Multiple teams will use the same studio domain. The company needs to ensure teams are isolated but can share common resources like VPC and S3s. What's the best configuration? Separate domains, separate user profiles in the single domain, separate AWS accounts, one shared user profile for each team. Separate user, let's see, single domain allows, is it B? Ooh. Yeah, okay, yeah, that's what I thought. Yeah, so the single domain allows, sharing VPC, S3, and common resources. Separate user profiles provide individual isolation. So each user has its own storage, execution role, and environment. The teams can collaborate through shared domain resources. It's cost-effective and easy to manage, and there's built-in access control per user. So the domain architecture, if it's shared, would be VPC, S3, KMS keys. Isolated per user would have the home directory, notebooks, and roles. Why are the other options wrong? So separate domains means they can't share resources. Defeats the purpose. Separate accounts is over-isolation and a complex cross-account setup. And a shared profile would be no isolation between them. 153. A model deployed on SageMaker needs to handle traffic from multiple regions with low latency. The model artifacts are stored in S3. What's the best multi-region deployment strategy? Deploy the model in one region with global accelerator, S3 cross-region replication with endpoints throughout 53, CloudFront to cache predictions, deploy the model in one region with VPC peering into other regions. So cross-region replication ensures model artifacts available in all regions. Multi-region endpoints provide true low latency. Route 53 geolocation routes direct to the nearest endpoint. High availability is available with regional redundancy. Disaster recovery is capable, and it's the lowest latency for global users. And you can see the architecture written out below. Why are the other options incorrect? So Global Accelerator improves the network performance, but it's a single region. CloudFront can't cache ML predictions. And VPC peering adds latency and doesn't provide regional redundancy. Question 154. Companies using SageMaker Autopilot to build a classification model. The dataset has 50 features, and the company wants to understand which features are most important. Where can the company find feature importance information? CloudWatch logs, Autopilot model explainability, SageMaker experiments, model monitor output. So Autopilot automatically generates explainability reports. This includes feature importance rankings, shows contributions of each feature to predictions, uses SHAP values for acceleration. It's available in Autopilot job output. There's no additional configuration needed. So the Autopilot explainability feature, this is a global feature importance. So it's across all predictions. The SHAP values are for each feature. The visualizations of the feature impact are available, and there's downloadable reports. Why are the other options wrong? Well, CloudWatch logs just contains execution logs. Experiments tracks trials, but not feature importance. And model monitor is for drift detection. 155. A company needs to retrain models monthly with new data. The retraining process should automatically start when new data arrives in S3, train the model, evaluate the performance, and deploy only if accuracy exceeds 85%. Which solution requires the least operational overhead? Step functions with Lambda, SageMaker pipelines with EventBridge, Glue, manual with CloudWatch events. B, so SageMaker pipelines are designed for these workflows. EventBridge will trigger on S3 events automatically. There's a built-in conditional step, so it'll deploy if the accuracy is above 85%. There's native SageMaker integration for training, evaluation, and deployment. Model registry is integrated, and it's the least operational overhead. And you can see the pipe flow. All right, so why are the other options wrong? So step functions is a general integration, right? That one you need more custom. Glue is for ETL. And manual, well, that's just gonna be too high overhead. All right, 156. Company wants to build a recommendation system for an e-commerce platform. The system needs to recommend products based on user browsing history, purchase history, and product attributes. The company wants a fully managed solution with minimal ML expertise. Which solution should the company use? SageMaker with factorization machines, Personalize, SageMaker with XGBoost, or Comprehend? Personalize. So, Personalize is purpose-built for recommendations. It's a fully managed service requiring minimal ML. It handles user item interaction data automatically. It provides multiple recommendation recipes like user personalization, similar items, and more. It supports real-time and batch recommendations. It automatically handles cold start problems, and it scales to millions of users and items. So Personalize has user-based recommendations, item-to-item similarity, personalized rankings, real-time updates, and it has no expertise required. So why are the other options wrong? Factorization machines requires machine learning expertise to implement and tune. XGBoost is not optimized for recommendations, and Comprehend is a neural language program. 157. An ML engineer is training a model on a dataset with missing values. The engineer wants to understand the pattern of missing data before deciding on an imputation strategy. What type of missing data pattern would allow the safest use of simple deletion? So, missing completely at random. So MCAR, missing at random, missing not at random, systematic missing data. A, MCAR. Missing completely at random means missing in this is independent of any variables. No systematic or pattern to the missing values. So it's safe to delete rows with missing values where no bias is introduced. And the deletion only reduces sample size, so it doesn't skew the results, and it's the simplest case for handling missing data. So MCAR characteristics include the probability of missing is the same for all observations. There's no relationship between missing values and any variable. So an example would be a random sensor failure, right? Why are the other options wrong? So MAR has the missingness is related to observed variables. So this introduces bias. MNAR, missingness is related to the missing value itself. So deletion bias will be there. And systematic, well, patterns exist, so the deletion will create bias. (158) Companies deploying a computer vision model for quality control and manufacturing. The model needs to produce 1,000 images per second with sub-second latency. Each image is 2 megabytes. Which SageMaker inference option meets these requirements? Serverless inference, real-time inference with multiple instances, asynchronous inference, or batch transformation? Real-time inference provides sub-second latency. Multiple instances handle 1,000 images per second throughput. The auto-scaling adjusts capacity based on traffic. A 2 megabyte payload within the real-time limits of 6 megabyte max. A dedicated instance ensures consistent performance. So this will meet the high throughput, low latency requirements. So capacity planning would be if one instance processes 100 images per second, you need 10 instances for 1,000 images per second. So auto-scaling handles the fluctuations. Why are the other options wrong? So serverless has a 4 megabyte payload limit, and cold starts are unsuitable for a consistent sub-second latency. Asynchronous is for longer processing times, not sub-second. And batch transformation is for offline batch processing, not real time. So read that question carefully. 159. A model for loan approval shows bias against certain demographic groups. The company needs to quantify and report on this bias for regulatory compliance. Which SageMaker feature should be used? Model monitor, debugger, clarify, experiments. SageMaker Clarify is designed specifically for bias detection. It quantifies bias metrics across demographic groups. It generates detailed bias reports for compliance measures. It measures pre-training and post-training bias. It provides fairness metrics, so disparate impact, demographic parity. It creates documentation for regulatory requirements, and it offers mitigation recommendations. So the Clarify bias metrics include class imbalance, difference in proportions of labels, disparate impacts, and demographic parity difference. Why are the other options wrong? So model monitor is for drift detection. Debugger is for training issues. Experiments is for tracking runs. 160. A company has trained multiple versions of a fraud detection model. They want to compare model performance across different versions using various metrics before selecting one for production. Which AWS service provides the best solution? CloudWatch dashboards, SageMaker experiments, CloudTrail, or QuickSight? B. SageMaker experiments is designed for tracking and comparing experiments. This organizes the multiple model versions, the trials, within experiments. So this automatically captures metrics, parameters, and artifacts. There's built-in visualization for comparing performance. It tracks all training configurations. It has easy comparison of accuracy, precision, recall across versions. It integrates with SageMaker training jobs. So experiments features side-by-side metric comparison, parameter tracking, artifact management, visual analytics, and search and filter capabilities. Why are the other options wrong? So CloudWatch is for general monitoring. It's not machine learning specific. CloudTrail is for API logging, and QuickSight is a business intelligence tool. So that'll be all of our questions for this one. And I wanted to say thank you for joining. Hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning exam. Until then, have a good day.